Okay, this is section 3.4, composition of transformations. So we're going to do more than one transformation today. We're going to look at it. We're on page 249, section 3.4 in geometry. And the word composition, if you look on it in music, means more than one. So in this case, we're going to do a composition. It means more than one. We're going to do more than one composition. So you might do a couple translations, reflections, things like that. But the first one is that we're going to deal with is called a glide reflection. Okay? A glide reflection. Glide is kind of another word for what? A glide, a slide. Okay? So you can say a glide reflection is a composition of a translation followed by a reflection. So we have a translation and then a reflection. Okay? And if you look at your worksheet, just so conveniently put away, if you look at your worksheet, the first thing that it says is triangle ABC has vertices A, B, and C. Graph it and its image after the indicated glide reflection. You can see that we have a translation along the vector 2, 0, and then reflection in the y-axis. So I'm going to look at that. You also have one in the x equals y or y equals x. I want to point out to you that 2 and 3, it's the same line. Y equals x and x equals y is the same line, and it's that diagonal. Remember that? And how did we get the points then? You had to memorize it. Remember how we got the points? You might have to look back up. Yeah, okay. You just switch the x and y's, okay? So I'm going to look at a glide reflection on this graph here. What is graph? Okay. Let's take a look at this glide reflection. So I'm going to do this 6, 1, 1, 2, 3, 4, 5, 6, 1. Do you guys need boards? I'm going to do 6 and negative 1. Okay. What's that? Do you want to do boards or do you want to just do graph paper?
Boards.
Okay, get the boards out. Let's make it a little smaller. I'm just going to make one up. Okay. Okay. Just so you get the right coordinates, A is 2, 3. A is 2, 3. B is 3, 4, 1. And C is 0 and negative 1. So those are your 3 points. Okay? All right, so what I want to do is, since it's a composition, I want to do the vector a negative 3, 2. Whoops. A negative 3, 2. That's the vector. And then let's reflect it over the x-axis. So we're going to reflect it over the x-axis. All right, so what I do is I take each one of these points and I move them. All right, so I'm going to move it a negative 3, 1, 2, 3, 1, 2. So A prime is here. Do we all understand that? Would you move B then the same amount? B is 1, 2, 3, 1, 2. So B prime is right there. I'm going to erase B prime and write it on the other side. So this is B prime. And then C prime is 1, 2, 3, 1, 2. Are there any questions about that? You will use this. You don't have to use straight edge right now, but please use a straight edge on your homework. Okay. Do we see that? Angel. Any questions? Kagan. Okay. So now we're going to reflect it over the x-axis, which is this axis right here. So I'm going to move A prime, I'm going to go to it and then away from it. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we're going to call this A double prime because it can't be A prime, can it? Okay? And so then I'm going to take B and I go 1, 2, 3, 1, 2, 3. B double prime is right there. And then C is one away from prime, it's C double prime. And so I have this particular one right here. And now I have shifted it, glided it to the left, and then reflected across the x-axis. Okay? And that's how you do those. All right? Any questions about that? Now, obviously, when it's y equals x on the 2 and the 3, when it's that one, okay, you're going to have to just take these points, the A prime points, and you're going to have to flip those. You understand what I'm saying? Tyra, you're going to take, if you're going to flip it on the y equals x ones, you're going to take these ordered pairs and flip the x and y. Okay? Not the original. The original was slid first, okay? All right, any questions about that? All right. So, I'm going to show you a couple compositions that actually produce something a little out of the ordinary. Okay, the first one is if we do reflection on parallel lines. And if you will turn to page 250. Oh, by the way, an isometry, I need to write this down. An isometry is a transformation that produces an image that is the same size as the pre-image. So an isometry has the same size when you're done. Okay? So what we just did was an isometry because we shifted it left and then we flipped it, but the size of it didn't change. Okay. All right, just so you know. Now, if we take two parallel lines, okay, and they're parallel here, and we have, let's say, a triangle here, okay? If we reflect it across this one, it ends up here, correct? Mm-hmm. And then if we reflect it and it flips, right? And then if we reflect it again over this one, you're going to get the same figure, aren't you? Because it just flipped twice and it's just slid over. So when you do a reflection over two parallel lines, it ends up being a translation. Does that make sense to you? And what's interesting is it's perpendicular to those lines as it's moved, and it's twice the distance of the two lines. So this, if you measure this distance, the distance from here to here is twice that distance. Okay, so here's your worksheet. 5, 6, 7, or 8. Which one has a reflection across two parallel lines? Number 7, right? Okay, now when you reflect 7 across this line, it's itself. Do you realize that? And then when you reflect it over this side, okay, you see that purple thing that I gave you? Okay, all right, that purple thing is called a Mira. Some people call it a Mira. And they like to call it a Mira because, can I see yours for a minute? They like to, okay, so this is a Mira, all right, and you can see this, it has a beveled edge right here. What do I mean by beveled? It's cut, okay? So if I want to take a triangle and I want to move it across the line like that, this will reflect it, okay? I don't know if you can see this. You can't see it because it's sideways, but if you put it up here, see the beveled edge? It goes up against that. If you can look on the same side as the triangle. See, I'm looking on this side, so I'm looking this way. My eyesight is this way. And what it does is it produces a triangle on the other side, and I just have to reflect it. And so it'll actually reflect it across there. And you can just draw it in. You see how I drew it? And I'm looking, if you looked at me instead of up there, you will see that I'm looking through here and it just reflects it there. So my eyesight is this way. Does everybody see that? Here, you better take this back so you can do it. Okay, so I want you to just practice on that number 7. You're going to put the Mira right here and you're going to reflect this triangle over here because this one's a reflection of itself, isn't it? So I'm just going to, and it should end up over here, correct? And if you did it real carefully, it should be about the same size, look the same way, only slid. Okay? All right. Does everybody understand the Mira? Okay? Any questions? Okay, we got to move on. You're going to use the Mira in a minute on those last ones. Okay, so that was a reflection of what? Over what?
2 parallel lines.
2 parallel lines. But we can also have a reflection over 2 intersecting lines, right? Take a look at the bottom ones. Right? Okay? That would be this one, right? And this one. It's also this one. Okay? Now, what you're going to do is, it says reflect it over line X and then line Y. Okay? So if you do line X, right, it's going to come down here, right? And you're going to use that Mira to reflect it. And then you go over Y, you're going to reflect it over here, right? Now, an interesting thing happens. What this produces is a rotation. Okay? It produces a rotation. And the rotation is about the point of intersection. It rotates about the point of intersection. You understand what I'm saying? So in other words, it's going to rotate around this point. Correct? All right. So once it does that, then through an angle, there's twice the measure of the acute angle or the right angle formed by the 2 lines. So it is twice the angle of rotation is twice the acute angle. All right? So if you take a look at this, right, it's going to flip. This is the acute angle. How do I know this is the acute angle? It's less than 90. So this is how big? Now, how big is this angle here? 60 degrees. So how big is my rotation going to be? 120. It's going to be double it. You understand what I'm saying? It's double the acute angle. Do we understand that? So I want you to begin with this one, and this one, and this one, these 4. And I want you to do it with the Mira first. So we don't have to work that out. And then Dylan will put the Miras away.
On number 5, reflect it over the X, and then you reflect it over the Y.
It says X and Y both on all of them. So you do the X-axis first and the Y.
Can you
Okay.
lift up your paper so I can see the
Say that again?
Can you lift up your paper so I can see the notes?
Yes. It's twice the acute angle. The angle of rotation is twice the acute angle, Kagan. Do you understand that? So this worksheet is due tomorrow. Okay? Do you have any questions before I stop.
On number 5, when you're reflecting over the pie, you use the original shape or do you use the shape that you just drew over
Oh
the
no,
X?
when you do 2 reflections, people, okay? When you do those 2 reflections, all right? That flag, whoops, I did the problem wrong. That flag, it looks like this. It looks like a flag or whatever, right?
Yeah.
Right. That flag, you reflect here, and then you take this image and reflect it over here. You always reflect the second image. So it's a double prime. So label it as a double prime. And I do want you to label them. Okay? Any other questions? That was a great question. All right. Get to work.